In this video, we're going to look at why the 45-45-90 triangle is special. We're going to be able to use that to evaluate our trig functions at 45 degrees. So to start, we just have a square, and we're cutting it along the diagonal here. So we're going to end up with one 45-45-90 triangle, 90 degree here. And then these angles right here are both 45 degrees. So let's go ahead and figure out the length of this diagonal just using Pythagorean theorem. So we're going to have x squared plus x squared is equal to the diagonal squared. These will just be 2x squared. All right, so we're solving for the diagonal, so I need to square root both sides. So we're going to get square root of 2 x squared is equal to d. The x squared, we can go ahead and pull that out. So we're going to get x on the outside. So x root 2 is equal to d. All right, x square root of 2. I'm going to go ahead and draw this triangle. I'll just draw it in the same orientation as that other one. So notice, because it was a square originally, this is an isosceles triangle, which is going to help us actually. X root 2. That just means that these legs are going to be equal to each other, which just makes everything nicer, easier to play with. So this is the ratio of the sides. If you have a right isosceles triangle ever, let's say, oh gosh, that looks terrible. Yeah, there we go. That'll work. If you knew that these two legs were equal to 5, you would automatically know, without doing any Pythagoras, you would know that this diagonal is going to be 5 root 2 units long. All right, this is always true. So if you ever see those the tiles that run along floors, if they are square units, if they're 1 unit, 1 foot that way and 1 foot this way, then the diagonal across them is going to be square root of 2. What we're going to do is we're actually going to use this one right here to define our 45-45-90. We're going to use this to find our trig functions at 45 degrees. So I'll go ahead and draw that. So we're just plugging in 1 for x. This is a basically small numbers that allow us to neatly describe the ratios of the sides for a 45-45-90 triangle. Okay,